Finished studying physical chemistry, let's check your understanding of Maxwell-Boltzmann curves. The distributions of molecular speeds are shown below for a gas at two temperatures T1 and T2, where T2 is higher than T1. The y-axis represents the fraction of molecules with speed mu. This is a very good question to understand the theory behind Maxwell-Boltzmann speed distribution. According to the Maxwell-Boltzmann theory, for an ideal gas, all molecules are in continuous random motion. No molecule is at rest. The distribution of molecular speeds depends on temperature. When temperature increases, the most probable speed increases. As a result, when at higher temperature, the distribution shifts to the right. The curve becomes broader. The peak height decreases. The area under the curve remains constant because it represents the total number of molecules, which does not change with temperature. An ideal Maxwell-Boltzmann curve starts from the origin, rises to a peak, gradually falls to zero at high speeds. Now let's have a look at the given answers. Curve 1. At higher temperature T2, the most probable speed has increased. However, when the curve shifts right, the peak height must decrease to keep the area constant. This reduction in peak height is not shown. Curve 2. Maxwell-Boltzmann theory assumes no stationary molecules. All the curves must start from the origin. Here, the curve at T2 does not start from the origin. Curve 3. Although the median speed behavior looks similar to curve 1, the area under the curve is larger at T2. This violates conservation of the total number of molecules curve 4. At higher temperature, the most probable speed has decreased. This is opposite to Maxwell-Boltzmann behavior. Curve 5. Both curves start from zero. At higher temperature, most probable speed is increased. Peak height is decreased. Curve is broader. Area under both curves is the same. This perfectly follows Maxwell-Boltzmann theory. Subscribe to our this week's newsletter and get an easy-to-follow short note on Maxwell-Boltzmann curves, along with a sample question discussion just like this one. Stay with us and boost your chemistry scores. Yours, Atom Academy.